everyone, welcome back to the channel. Today in this video we will learn how to write the automation test cases for the Terraform Azure storage account module. As you can see, I've just now run the test automation for the Azure storage account module on my local machine. It has run the test cases, destroyed, and then this is the result of the test cases. So I'll show you how do you begin writing these kind of test cases for your own modules and make your infrastructure's code more robust. The reference of this source code will be available as in GitHub repository. The link of the GitHub repository is given in the description. So please follow me with the approach how to write it and refer the link which is given. So here in the Visual Studio Code, first of all, you need to have the Terraform module for which you would like to run the test cases or for which you would like to create or write the test cases. So this is my storage account module. Here in the module, I have the main.tf in which I have defined the provider. Provider is necessary in case if you would like to run your test cases of this module. So apart from the provider, I have the resource block, which is the Azure RM underscore storage account. This resource block is totally depends upon you. How do you want to write your Azure storage account resource block? As per my own requirement, I've defined my own parameters and then created the storage account module based upon that. But you might have the resource block which has a different set of parameters or different kind of parameters which you are expecting for this module to be passed on. Apart from this, I have the output.tf which is basically returning certain number of outputs once the Terraform code for this module or for this resource block will be executed. For an example, I am returning the resource ID, name, primary location, blob endpoint, and there are some other details which I'm returning as part of this particular module. Next, I have the variable file, variable.tf, in which I am asking user or consumer of this module to provide the parameters such as the name of the storage account, resource group name, location name, tags, and then additional setting as an object type. Next, I have a variable file created just for this particular test case execution. So instead of providing the value as in inline parameters, I'm trying to provide the value as in parameter files. So that's why I've used the test.tf var file. So here are the list of variables, whatever I have declared in the variable.tf. I'm providing those values here. Now to create the test case, first thing you need to do is you need to create a folder named test inside the module folder itself. You can see that this is my module folder, and inside the module folder I have created a folder named test. Now in this folder, if I expand that, you need to create a Go file which is of type Golang, right? So the test case which we are going to write with the help of terratest, which is the module of the Golang, Now this means that we have to first of all install the Golang on the machine in which the test cases are supposed to run. To install the Golang, simply you can search, download and install Golang, and you can download the latest version which is available on this official website. Install it on the machine. It is fairly easy. So depending upon the operating system, you can install the version of Golang. Now, as I have already installed the Golang, next thing what I have done is I have installed this particular extension on the Visual Studio Code, which is Go version 0.39.1. I recommend that you install this on your machine as well. Now coming back to the test. So this is my test file. I've given it a name as in main_test.go. Now Go is the extension of the Golang file. Now if we go back to the top, first thing you have to write, or the first line you have to declare in this particular file, is the name of the package, because this Go file is nothing just a package which you are creating. and whatever code you write inside this particular package is going to be executed as a package. Like if I write the number of test cases which are supposed to be run or executed, then those will be executed as a package with this particular name. So the package name I have given as test. If you want, you can give any different package names. Next you have to add is the import section. Import section basically requires, in case if your test cases or if in case your Go language code requires to use any third party or system defined Go language package. For an example, we have a package which we are using called the testing. Then there were some package which is commented out, as you can see, operating system, file path. Then there is a package called format which can be used to format a string. Then there is a package called string which is used. I'll show you where exactly it is used. You can see that here in the line number 24. In case if you would like to use a string functions like to upper, to lower, concatenate and all those things, you can use this particular package. Now, apart from this system defined package, we are using a third party package which are provided by terragrunt. As I mentioned in the beginning, the terraform test cases are going to be run as in terratest, which is the module of terragrunt provided by terragrunt as an organization. So terragrunt has provided a certain number of packages which you can use to write your terraform test cases. So the package can be specified with this particular URL, which is github.com/gruntwork-io terratest/module/random. So this is a random package which we'll be using. Next we are using a terraform test. So same URL, it's just the end you have to use the terraform. Apart from this, we are also using package which is provided by structure, and this is for testifying the assertion. So as we are going to run or write our test cases, and after the test cases we will compare our test case result with the help of the assertions. Hence we need this particular package. Moving forward from line number 17 to 19, I have the constant defined. So any number of constant variables which you would like to define on this particular Go language package which you are creating, you can define with this constant keyword. And this is the boundary of the constant, which is small opening bracket and small closing bracket, and in between these you have all your constant. So constant name we have declared as in fixtures, which is basically showing the directory location for your Terraform module. So as we know that the directory location for the Terraform module is one level up from this test directory. So that's why it is used as :/. Next you have the var keyword with opening bracket, closing bracket, and we are defining all the required variables which are needed for this particular code. For an example, the variable for defining the backend configuration, if you want to use variable for defining any environment variable, this is just a declaration of those variable in these two cases. Here in this case, we are generating a unique postfix for an example, and then I have used an expected underscore name variable wherein I am providing the name of the storage account which I will be comparing it with, right? Apart from this, you can also create a private functions or the functions or method inside your Golang package. So this is a commented code, but just for the information, in case let's say if you want to run the Terraform code from the pipeline, then you may want to run the Terraform code with your service principal. So how do you set and get the service principal? You may create a function or a method with name, let's say set Terraform variable, you can call it anything, and then basically you can get the value of the secrets like client ID, client secret, tenant ID, subscription ID, so that you can run the Terraform like this. You can get it like this, and then you can set these variables to the global variable which we have declared it here, global environment variable, right? As of now, I have commented out because for this demonstration, I am going to run the Terraform code from locally using my Azure login credentials. So I'm not using any service principal, but if in case if you are using a service principal, this is what you can do. So code will be available in case if you are using it, you can simply uncomment this and you can use it. Next, I have defined a type, a structure. Basically, the type name is given as a condition, which is of type int, and then this type I'm using it with another set of constants. So again, I have defined a constant, and I'm using declaring three different constant which is of type test condition, which we have declared here. Right now, why we are doing that, I'll show you later, which is at the stage where these constants are used in the program. Next, you have the terraform options function. So there is a terraform option function. You can call this function name anything, but remember that it is pointing a pointer to terraform.options. So this is a pointer symbol. You have to remember that. So this is important. Pointer terraform.option, and then this function is returning an address of terraform.options with this set of parameters. Where is the directory of the terraform? Okay, so directory of the terraform are captured from this constant variable which we have declared at the top. Now next is, where is the variable file? Do we want to use a variable file to run your terraform code? Yes, we are using this particular variable file, which is test.tf file. So I've given the name of that variable file here. Now apart from this terraform option, which is a method of basically your terragrant module, there are certain other parameters or attributes which you can specify. For example, if you don't want to use a variable file, if you want to use inline variable for your module, then you can use it like this: var colon, then the set of variables which you want to set or specify as in vars, right? Next, you have the environment variables. In case if you want, if your terraform code is supposed to use any environment variables like global variables, you can specify those environment variables like this. In case if your terraform code is using or supposed to use any backend configuration, as of for this example, I'm not using any backend configuration, but it may possible in your case you want to run your test cases with remote backend configuration. If that is the case, then you can specify the remote backend configuration with this option. No color, in case your terraform logs or the terraform console output which is return, if you want to return it with the help of a color, which is a default option, or if you want to remove the color option, then you can specify this option as well. So this is a method, this is the constant. Now as of now, these constant and methods are not used anywhere. Now where are we going to use? We are going to use it in our test method. So we have to declare or write or specify a test methods. How do we specify? Same function keyword func space. Now you have to use the test keyword as an prefix, because when you use the test keyword as an prefix, terraform test keyword as in prefix, Golang automatically determines that this method is a test method, and when you run the terraform test command, when you run the Golang test command, it will use this method as a test method, and it will execute the code which is written in this particular test method. Now if you do not declare this method name as in test as a prefix, then this will not be considered as a test case or test method, and it will be ignored, and your Golang will say that no test cases found. So this is really important, that when you declare your method name, you give the method name as in test with a prefix. Underscore is optional. I have given the underscore just to show you the difference between this prefix and the other part of the prefix, or which is the method name. So I've given the name as in test underscore automation. You can call it anything, but remember that the prefix is there. Next, this is an argument of the test object itself. Then you have the do you want to run your test cases parallelly? So this is a test parallel method, right? Now this all is of part of this particular testing block, testing module, right? So the module which we have declared it here is being used here in this particular method as in parameter type, right? So that is why this import of this is very important. Now we have seen the import use of this string type here on line number 24. We have used this as well, right? As and when we go, we will check the other things as well. For an example, terraform.init apply and idempotent. Here we are using Terraform. So Terraform is again coming from this Terraform Terragrunt or terratest module. So this is a part of this, right? Now here what we are saying, when it will run the Terraform, it will run the Terraform initialization, it will run the Terraform apply, and it will run it as an idempotent, which means that there will not be the parallel Terraform run execute once this is running. So if you, in case if there are multiple processes trying to run it, so it will not run execute multiple of them at the same time. Here we are calling this method, which is where we have declared the Terraform option, which has the detail about Terraform variables, directory, and all those things. So you can see that as part of this method, which is terraform.initialization and apply, we are calling this method. In the next line, we have used the next method, terraform.destroy, and again passing the same Terraform option method, which is the argument which we have specified. Here in this case, we are using a default keyword. Default keyword is used to make sure that irrespective of any other line of code which is going to be failed, this default method will make sure that the destroy method always runs. What do I mean by that? Let's say that you run the Terraform initialization and apply. Terraform creates your resources, but while running the test cases, it has failed. Now, if it has failed, the Terraform or the Golang test cases will exit the program, and in that case your resource will keep on hanging on your infrastructure, and your client may require to pay for that because you have provisioned those resources, and next time when you run it will say that the resources are already created. So to make sure that irrespective of the test cases pass or fail, you are destroying the resources once it is created and tested. So that is why you use the keyword defer, right? Next thing what we have is run output validation. So what we have done is we have created a method, a run output validation, which is the name of the method output we have given, and then this is the method we are calling. So where is this method? We have this method here after at the bottom. I'll come to the discussion or the explanation of this method, what it does. But before that, let's say if you do not want to have a different method, you may found that you can have the assertion right here in this test automation method itself. But for the simplicity and for the cleaning approach, I have created a different method for the validation, but you could have also done the output validations in line. For an example, in this case, we are trying to get an output after your Terraform apply runs. It will generate the output, which whatever output is written in your program in your Terraform module. You will take out the output values, all the output values, and then you may want to basically perform the assertion. For example, you are using require equals, assert dot equal, assert not empty, assert contains, and all those things, right? So that's one way you can have those assertion right here inline in this test method itself, or like I am doing it here, which is the preferred method. You can simply create a output validation method, and in this output validation method, same testing reference we are passing, and what we are doing here is we are declaring an structure, which is the name of the structure is test cases, and here we have given the structure schema as an name, which is of type string, got is type of string, want as a type of string, and condition is of type test condition. Remember the test condition we have created at the top, this is the type. So test condition type, any test condition type which we have declared, now it is going to be used here. So this is my structure which we have declared. Now in this structure we are initializing as an array, because you can see that this test case is an array of structure, right? So here in this array, we are defining the number of test cases. For an example, the first element of an array is this structure, which is the name of the test cases, storage account name, right? So basically we are saying that validate the storage account name, right? Next, and the next parameter is got. So what we got is Terraform output So this is what we got. So it will take the output and it will set the output values into a got parameter. Next, expected name, the variable which we have declared at the top, want. So we want this, so we are setting this expected name into a want parameter. And then test condition, what condition we want to use. So what we are saying is our test condition should be equals, test condition equal. Now where exactly this test condition equal is coming from? So this is of type test condition. So remember, we have declared this test condition. So this is the test condition variable which is of type test condition. So test condition equal, in this case we are using. Next test case, primary location, okay, which is the name of the test case. Then this is what we have got, which is output. Here in this case we are not comparing with anything, so I'm keeping this as an empty. What is your test condition? Not empty. So this is my test condition. Next, resource ID, again the test condition is not empty. Next, primary blob endpoint, test condition, let's check that, test condition equals, right? So these are my test cases, 4 test cases which I have specified or declared as an structure array, which is the name of the structure array is test. Now this test structure array, I'm using it inside this for loop. So with the Golang, you have the for loop like this, starting from for each element of this array which is which will be captured inside the TC. You run the tc.name and then you specify the condition, right? Switch case condition, tc.condition, right? So condition will be, in this case, if is it a condition equals to, it will go inside this particular case and it will run this assert. If it is a condition not empty, it will go inside this assert. If it is a condition contains, it will go inside. So as many as assert condition you want, you do not have to repeat your code again and again. This is a very interesting and quality code wherein you are specifying your assert, and depending upon number of test cases you might have, you do not have to repeat your assert. You simply just creating a collection of those test cases and executing the collection as in for loop, right? And that's the way. And now if you try and review this code again, this will work absolutely fine. I'll show you how does it looks like. Let me just clean this up, which was the last run before I run it. So now to run your test cases, what you need to do is, first thing you need to do is you need to initialize your module. So initialize your package. So remember the name of the package what we have. So name of the package is this test. So the command which I'll run is terrafrom go space mod init command and then space the name of the package which is test. Now as soon as you run this command, it will ask you to run go space mod space tidy command. So that's the command which will run. So what it will do is, it has created a go.mod command, module command. Now it will download all the packages which is mentioned to import as to run this particular package file. So these are my packages which will be imported into a file. So now you can see that as soon as it finishes the go mod tidy command, you will have the code. As I mentioned, it is downloading all those packages which we have asked to import, and once import is completed, this command will be finished. Now next thing you have to do is you have to run the command which is the test command, and the command is go space test space -v, and -v is for the current directory in which we are right now. So it will use the packages which are mentioned inside this current directory and will execute those packages. As expected, the Terraform initialization has started and completed. Now it's running the Terraform apply command with the variable file test.tf-var files. Storage account created successfully, and after that it has taken the output as well, and then it is running the test cases as you can see here. So all the 4 test cases are run, and finally it is running the Terraform destroy to destroy the resources, and that's it. The test cases are completed successfully, and this is what we want. I hope you have found this useful, and you would be able to run your test cases or create your test cases with Terraform for the storage account module. Just for the information, I have added this code along with the module and the test cases here in this repository. In case if you would like to refer to the source code, you can refer it right here from this particular repository link. I'll share this link in the description, and I hope you have found this useful. Please subscribe to the channel if you haven't already. Thanks for watching the channel. Thanks for watching it. See you in the next video.